Did you know that particles can be in two places at once? Welcome to the strange world of quantum physics. This field of study dives into the smallest particles in the universe, where rules of classical physics just don't apply. Here we encounter the concept of superposition. It's a peculiar principle stating that a particle can exist in multiple states simultaneously. Picture it like this. It's as if you were to sit and stand at the same time. Sounds impossible, right? Now, let's delve into the famous Schrödinger's cat thought experiment to illustrate this concept. Picture a cat in a box, both alive and dead at the same time, until you open the box to check. Bizarre, isn't it? This is the essence of superposition. So, in the quantum world, reality is a bit fuzzy. Until you look, you never know what you might find. Imagine being able to feel what your friend feels, no matter how far apart you are. That's quantum entanglement for you. Now don't start thinking about telepathy or some sci-fi magic trick. This is pure, unadulterated physics at its most mysterious. Quantum entanglement is a peculiar phenomenon where particles become inextricably linked, and the state of one can instantly affect the other, regardless of the distance between them. Think of it like this. You have a pair of dice. You roll them in New York and Los Angeles at the same time. And every time they show the same number. That's pretty spooky, right? Even Einstein thought so. He was skeptical about this spooky action at a distance, as he called it. But experiments have confirmed its existence time and again. So, quantum entanglement shows us that distance might not mean much in the quantum world. The universe is far more interconnected than we can comprehend. Want to know a particle's speed and position? Sorry, but you can't have both. That's the uncertainty principle. This is the Heisenberg uncertainty principle, a cornerstone of quantum physics. It's a bit like trying to catch a raindrop in your hand, only to see it slip through your fingers. Now, you might be thinking, wait a minute, what do you mean I can't know both? It's not that you're not clever enough, it's just how the quantum world operates. The more accurately we try to pinpoint a particle's position, the fuzzier our understanding of its speed becomes, and vice versa. This isn't because of any limitations in our equipment or techniques. No, it's a fundamental aspect of nature itself. It's as if the universe has decided that certain pairs of information, like a particle's position and speed, are too much for anyone to know simultaneously. So, the more precisely we try to measure one quantity, the less precisely we can know the other. The quantum world is full of such trade-offs. What if you could jump from one floor of a building to another without passing through the floors in between? That's a quantum leap. Imagine this. An electron, living in its own little world, decides it wants to change its energy level. It doesn't climb an energy ladder, it doesn't take an energy elevator, it simply jumps, or rather it leaps from one energy level to another without passing through the space in between. Sounds like magic, doesn't it? But it's not. This is quantum physics. This phenomenon, known as a quantum leap, defies our regular understanding of the world. In our daily lives, we move through space and time in a linear fashion. But electrons? They dance to a different tune. They can be here, there, and everywhere, all at once. They break the rules, bending our understanding of reality. So, in the quantum world, particles can take shortcuts that are impossible in our everyday reality. Quantum physics might sound like science fiction, but it's very real, and it's all around us. We've embarked on a captivating journey exploring the fascinating realm of quantum physics. We've delved into the quantum conundrum of superposition, the eerie ability of particles to exist in multiple states at once. We've unraveled the entanglement enigma, a phenomenon so strange it baffled even Einstein, where particles, no matter how far apart, are intertwined in their states. We've grappled with the uncertainty principle, the bizarre rule that you can't know both the position and momentum of a particle at the same time. And we've leaped into the phenomenon of quantum leaps, where particles can jump from one energy level to another without passing through the space in between. These are not just theoretical musings, but fundamental aspects of our universe. So, next time when you think about reality, remember, it's far stranger and more fascinating than you might imagine. That's the wonder of quantum physics.